Awesome. Hello, everyone from dialing in from around the world. My name is JP, and I'm a technical advisor with ThorChain. And I'm here on invite to discuss how ThorChain can secure external assets just using multi-party computation and incentives. So ThorChain is essentially a decentralized liquidity network. You can think of it as a cross-chain Uniswap. The biggest difference is it's able to create pools across different chains just using the native assets themselves. So the first question you might have is, how is this possible to secure these external assets, which I hope I'll be able to answer with you today. And then the next question is, how is ThorChain able to detect the value of these assets in order to secure them, to ensure that the security of the assets is always essentially linear to what's in the system. So today I'll hopefully answer all those questions. Feel free to interrupt me, just pop in a question, and our host today will basically bump the question with me, and I'll get to answer it. This will take about 30 minutes. Please feel free to just jump in and ask questions. But today I'm going to answer in three sections. First of all, how ThorChain is able to observe external chains without using the very opinionated bridges, which you might be familiar with. Two, how ThorChain uses multi-party computation being threshold signature schemes. And three, how it's able to scale security. Cool. So ThorChain is basically it's a side chain for any external chain. And I'm just going to pop up this screen here, which discusses the technology side of ThorChain. So the team refer to this as one-way state pegs as opposed to a two-way asset peg. The reason why they call it a one-way state peg is because it only seeks to sync across state from an external chain. It doesn't try to wrap tokens. It doesn't try to peg assets. It's simply, in a continuous fashion, syncing across state into its state machine. Once the state is in a state machine, it's able to compute business logic, and then that business logic is swapping, adding liquidity, remove liquidity, and then it's able to delegate this into a continuously running MPC protocol using distributed key signing. And it's then able to compute, sign, and send out finalized transactions back onto the external chain. So the way to think about ThorChain state machine is that it's just an elaborate spending criteria evaluator. Now I want to highlight that, and I've just flipped across to the Bitcoin Explorer. So let's go to the latest block and scroll down to just any UTXO is fine. When you spend Bitcoin, you actually spend it with a spending script, and you hash that script and put it on chain. So for example, this Bitcoin UTXO here, which spends to this pay to script hash address, starts with 3, essentially writes into the Bitcoin ledger that this is the spending criteria for the future owner of this UTXO in order to spend. So Bitcoin will accept any signature on chain which meets this spending script. If it's able to essentially validate true, then it will allow this UTXO to be consumed into and spend it into new UTXOs. So all Bitcoin does is evaluate spending scripts. Now you might be surprised to learn that you can actually create anyone can spend spending scripts, which is a foolish idea because anyone can spend new UTXOs. The most typical ones are what we've seen over the time of the Bitcoin ledger is, pay to public key hash, or the new ones being pay to script hash, essentially taking a hash of the script, and then that is the criteria. So the way to think of ThorChain is it's a more elaborate spending script evaluator. The rules to spend, when you spend your UTXO into a ThorChain state machine, the spending scripts are all part of essentially the state machine of ThorChain. And you can evaluate these spending criteria and these spending rules yourself. So I'm just going to go into the swap.go file. So this swap.go file runs on every Thor node, and it basically evaluates spending criteria. Now, one of the ones you might be interested in is this one here. This is the 5 lines of code that determine essentially if you spend in a number of Bitcoin, how much in USDT or Ether or the output asset you'll get. So this spending rule here is run on every single Thor node. And when you spend into the Bitcoin state machine, they will evaluate the script here and spend it out and consume that UTXO and spend it back out. So hopefully you're able to see that ThorChain is just a very elaborate and complex spending criteria evaluator that looks at transactions on Bitcoin, Ethereum, Binance Chain, and more. So that is how to think of ThorChain. And I'm just going to go back to this notion of one-way state pegs. When ThorChain is continuously observing external chains, Bitcoin, Ethereum, Binance Chain, it doesn't matter. They run essentially a Bifrost service. The Bifrost service scans the chain and is able to build up a type of standardized transaction input. The transaction input simply contains the TXID, the originating chain, the from and to address. For something like Monero or other CryptoNote coins, this from address will be null, but that's okay. We don't need it actually. The amount of coins that are spent in the incoming transaction, the gas that was paid, and finally this memo. This memo is an on-chain instruction that is passed into the state machine that is able to transfer user intent. What is the user trying to do? Are they adding liquidity, removing liquidity, minting a synthetic asset, swapping to another coin on another chain? There's something like that. So once ThorChain is able to read in, every single node will essentially fill out this witness transaction. So assuming 36 nodes, and I'm just going to flick across the current dashboard. The current live network has 36 active nodes with 21 on standby. It churns every couple of days. So these 36 nodes will each broadcast 36 copies of this TXN. Now, assuming that they're all running their own nodes and assuming they're all up to date, then they will each broadcast a standard TXN. So they will all be identical. As long as they are identical, they are passed into basically the ThorChain state machine. And once we have 24 observations which are identical, ThorChain is able to basically move that transaction into a finalized transaction. So you can see it here. A single node runs Bitcoin, Ethereum, Binance nodes. By the way, these don't need to be full nodes. They can be light nodes or heavily pruned or warp sync, because the observers are only interested in what's happening at the chain tip. You can run these on remote nodes, so rely on an external service, but keep in mind you could be vulnerable to an Eclipse attack where your remote node is trying to feed you fake information. So that's why it's preferable that observers run as a minimum light nodes. The observer, like I said, passes all these witness transactions in. Once the transaction is finalized, i.e. we have at least 24 nodes reported the identical thing, in around about, I think the time flexibility is about 15 minutes. So they've got 15 minutes to report the same thing, else if they don't, they get slashed. As long as they report the same thing, that transaction is then passed in state machine and ordered in terms of its priority. ThorChain has essentially its own, essentially a swap queue where it tries to order incoming transactions based on importance to the system. Important transactions are those that create good price discovery of the underlying pools and also create the maximum revenue for the system. Once the transaction is ordered, then the state change is computed. If it's an outgoing transaction, like a swap or a remove liquidity, then it's delegated to a vault. I'll explain vaults in a second. And then this TX out is the instructions to spend. Now you might, as an aside, ThorChain is able to combat front running because there's no way to prioritize your transaction on an external chain by maxing out your gas. Because I could pass in a transaction in Ethereum with 20 GWay and get it finalized within a block or two. Or let's just say 20 GWay is enough to get it finalized within a block. You could try and front run me with 200 GWay, but we'll both get confirmed in the same block. Therefore, we'll both get witnessed into ThorChain regardless of the gas that we spent. And then ThorChain will then choose whose transaction is more important. And that only comes down to the revenue that we're willing to pay. And the revenue we're willing to pay is the size of the transaction. So you can't front run transactions by spending massively on gas on external networks. So that's how ThorChain works in that regard. Now onto this TX out. This TX out item is simply saying, on this chain, spend to this address from this vault, and a specified vault with the public key. This amount of coins could be Bitcoin, USDT, ETH. The memo is used for just accounting reasons. So it's able to, when it creates this TX out, essentially refer to the input transaction, which instigated this. So the third-party services can know that the accounting is all correct. The maximum gas, so the max gas is specified to prevent attacks on the system. So nodes can spend up to that maximum gas. and the in hash, which created it, and finally the out hash, which is followed up when that transaction is finally broadcast. This then goes to the signing routine. So we can see here that each node, which is also running a ThorChain validator, doesn't download this finalized transaction from some remote service because they've already computed the block. They've already committed that block and voted on it as part of Tendermint block construction. So they actually, this finalized transaction, they're querying from local KV store. This transaction goes into the signer, broadcasts back into chain client and back into TSS. So that's how it's able to spend. Now onto threshold signature schemes. The routine that is used is the one from Gennaro Goldfeder called GG18. This was a breakthrough because it was able to do so with a no trusted dealer. It's essentially fast trusted setup. So previous schemes before this required a trusted dealer. So there would need to be someone in the very start of it to cut up essentially the signature schemes, whereas GG18 came through with a solution for that. There has been an update to this called GG20, which comes with provable blame and a few other neat things, and the team have started to implement that. So I'm just showing you live here the code here. There's essentially two main parts to TSS: the ability to create keys and the ability to sign on those keys. So if we just have a quick dig into ThorChain to see a current live vault and what it looks like. There's a seed service that basically broadcasts the current nodes. You can grab any one of these and then just paste it into that endpoint. And all you're doing is asking for the latest inbound vault. If you don't trust the system, you don't trust the seed service, then you should do it multiple times. So grab another IP address, which I'm doing here right now, and then just paste it in and replace that. Sorry. Cool, so there it is there. And then we're able to grab that. Essentially, this is the inbound vault to this chain. We'll throw it up in the Explorer, and we should see all the assets of the system. So here it is here. We've got large quantities of BNB, USDT, Bitcoin B, etc. This public address is the address for the primary inbound vault. There is no private key to this address. The transactions, these outgoing transactions, are only completed when 24 nodes, so these nodes here, they come together and they're nominated by the system to do so and sign these outgoing transactions. So this is an outgoing transaction from the vault. These inputs are all users adding liquidity, swapping, etc. We'll have a look at this one. So this is a Yggdrasil funding transaction. So the other thing I might have glossed over is the fact that signing TSS takes about 15 seconds. So the system would be massively constrained if it could only sign once every 15 seconds. There's a few other ways that the system tries to counter that. One of the ways it does is it splits up the vaults. So it has a primary large inbound vault called the Asgard vault, and then each node essentially runs a hot vault, and they are nominated to sign these outgoing transactions. So we can see that with 36 hot vaults, the system can do 36 times, about 10 times faster throughput. So massive increase of throughput by basically breaking up the vaults from one large TSS vault and 36 really small ones. The nodes can't steal any of these assets because of the incentive module. This game turn a second. So we can see here, these are all these outgoing transactions, swaps and double swaps from a node, which is able to do so because the state machine has delegated to it. And the node has committed large amounts of capital to participate in the system. Continuing on from this, so we found the Asgard vault. We took a look at the Asgard vault and a typical transaction. Now, one thing I might add is if you don't trust anything, you can write a script like this, and I'll just run it live for you. So what it's doing is it grabs the seed endpoint. In future, this will be located in a Web3 contract. And it basically is able to go through and it's basically get Byzantine. So I've just run the script and it's told me that it trusts this IP address. The way it's able to determine that is because it basically gets all the nodes off the seed endpoint, there's 36 nodes. It goes through and challenges every single IP for the pool address in order to get Byzantine. And once it's determined that it's correct, so there we go, so it fetches the pool address from every node, then it's able to basically say, hey, every node agrees, therefore I'm being massively Eclipse attacked, or B, this IP address can be trusted for the next amount of time. So yeah, you can be as paranoid as you want, and you should be paranoid at all times to basically cross-reference. But yeah, this script is an example of how to get consensus from a group of remote services. Cool. So that hopefully I've explained how the system is able to manage its vaults by using a state machine to process inbounds. And we'll quickly have a look at these inbounds. So if you just go onto the Live Block Explorer and you go to latest transactions, you can see these are all outbound transactions. Let me just go to one that's in. Okay, so this here is an observation of an inbound. So we can see here, this node is observing that 1500 Rune has entered the system, and it looks like it was swapped into Bitcoin. So you can see here that here's the 36 witnesses. So each node is saying, hey, I saw the same thing. Hey, I saw the same thing, et cetera, et cetera. So the system is able to, once it hits 24 observations, go, okay, you know what, I've got enough consensus. I believe that a 1500 Rune has entered the system. And the most important thing is essentially the memo. So this has got user intent, and the user wishes to swap into Bitcoin. And this is the price limit. So then the state machine is able to execute that. And what do you know, the very next transaction that we saw was that outbound transaction. So it's this one here. So this is going to use it. And if we actually pull up this transaction ID, we can actually see which node vault it came from. So that was that swap to BNB, and it came from this user, and it's going to, sorry, from this vault, and it's going to this user. Okay, so that's how the system works. We'll actually take a look at the live network. So this is the live network you can interact with, and because I've got a wallet attached, we might as well go through a demo of such a thing. So if I go into, say, I want to swap some BNB into Bitcoin. Let me just select that. So I'll swap some BNB into, by the way, this is Binance wrap Bitcoin. Like I said, Thorchain doesn't wrap Bitcoin. So this is, Bitcoin B is just an asset that Binance maintain on the Binance ledger. The reason why Binance was chosen as the first chain to connect to Thorchain was because it's an easy chain to connect to. It's also built on Cosmos. It has fast finality, instant finality. Gas fees are very easy to reason about. So it's been a very easy chain to build the system to. But the team have got Bitcoin and Ethereum currently in testing, about to deploy. So let me just go through this test. So I'm going to swap one BNB into this amount of Bitcoin. I might just do a little bit more. So 10 BNB into 0.015 Bitcoin. So I'll just go for the swap. And excuse me 1 second. Cool. So we'll follow the transaction through. And let me just bring that up again. So we broadcast the transaction. So if we pull up that transaction here, we should see this is me with my assets, 10 BNB, and this is my user intent. I wish to swap into Bitcoin. So then if I go back into, we can see the transaction has been complete. So we're just going to find that outbound transaction, which you can do by jumping in the transactions. While that happens, if we go into the latest transactions, we should see all the nodes observing. So just scroll back in time. You can see this is me. I've swapped my 10 BNB, and the user intent has been passed, and it's this one here. So, and then the outgoing transaction is this one here. So 10 BNB into 0.02 Bitcoin B. I'll just grab that up, and we can see here, this is the memo which referenced my input and the outbound amount of assets. And this came from one of the user vaults, which is funded by Asgard. Okay, so that was a live demo. So you can see it actually works. By the way, this is on mainnet, so this is real money, real funds at stake. Thorchain currently has about $50 million locked up in that system, which is partially made up of the pooled reserve, the pooled assets, the bonded assets which secure the pooled assets, and then finally the reserve which pays out to the system. I've got 10 minutes left, so I'm now going to discuss how the system is able to guarantee economic security of these assets. So the good diagram to view this is essentially this one here. Nodes are essentially encouraged to bond capital, and we'll talk about why they're encouraged to do so, at a rate that is 2 to 1 the amount of staked capital. So each pool has the external assets, say Ether, BNB, Bitcoin, all in its pools, and then it's got Rune as the settlement asset. Now, some of you might be nervous about the things like impermanent loss, you know, the notion that you don't want to hold an external asset that you don't, you're not familiar with. But as we reason about this and just explore, we realize that having Rune as the settlement asset solves a lot of problems. One, it solves the order n squared problem. So with 10 pairs, so 10 assets, you only need 10 pools. But if you allowed an arbitrary pairing, then 10 assets could create 10 times 10, sorry, 10 times 9, so 90 pools. So it dilutes liquidity. So having a single settlement asset solves the order n squared problem. So it keeps the pools small, the pool count small, and the liquidity deep. Two, it allows the system to detect the value of the external assets, because anyone can interact with these pools and arbitrage. So when these assets are up, there's no, so if I go into say the, I'm just gonna refresh this. If I go to the USDT pool, there's two stablecoin pools here. There's the USDT, which currently has a pool price of $1.002, and the Binance USD pool, which is a pool price of $1. So you can see that the system doesn't arbitrage, only users do. And through the act of arbitrage, these two stablecoins are essentially at parity with each other. So that demonstrates the system, that users can interact with the system in order to ensure that the assets in the pools are always the correct market price. If they're not the correct market price, then profit is to be made by someone. So getting back to how this, I'm just pulling up this diagram here. So the system is able to sense the value of the assets in its pools, so that the amount of Rune in the pools equals in value the amount of the value of the assets in the pools. Now, all that ThorChain needs to do is to ensure the amount of Rune bonded by nodes is always double the amount of pooled Rune. And it does this through something called the incentive pendulum. And I'm just going to pull that up now. The incentive pendulum is essentially splits up the system income and either pays the nodes or it pays the pools. So every 5 seconds, a block reward is produced. It's currently about $5 every 5 seconds. And it pays either, like I said, liquidity pools, so directly into the liquidity pools, or pays the nodes. So then we can essentially determine, based on the ratio of bonded to pooled Rune, that the most optimal scenario is 2/3 of Rune is bonded and 1/3 is pooled. And because that 1/3 of Rune is paired to the assets, then the amount of capital that the nodes commit to the system is always equal to double the amount of capital that they are securing, so that no node is ever incentivized to collude and steal, because they would be stealing less assets than they've committed into the system. If the system becomes unsafe, then there's too little Rune bonded and too much Rune pooled. So it starts paying node operators more of that incentive. So increase the incentives for those node operators because it's now in an unsafe state. Now, because it's now diverting income away from the pools, liquidity providers will start seeing basically adverse liquidity conditions. So they, if they are profit seeking, should withdraw their liquidity, essentially reduce the risk of the system. If the system is inefficient, which means there's too much Rune bonded and too little Rune pooled, then most of the rewards will go to the liquidity providers. So now they increase the incentives for essentially LPs to add their capital. And these nodes are not getting paid much. So there should be a decrease in how much is bonded. That's able to how the system is able to continually retarget safety, a balance of safety and capital efficiency, so that the system can grow with the value of its assets. You can actually see this live right now. So if you go to network, go to details, you can see this is the block reward, and this is how much is being paid into the pools, and this is how much is being paid into the bonders. The current pool share factor is determining where to split it. So currently 44% of the reward is going into liquidity pools. And like I said, this is based purely on the ratio between how much is bonded and pooled. Another way to think about it is on this dashboard here. You can see the system is optimal, but it looks like it's over bonded. So that means these nodes are bonding too much Rune. We just scroll down here. The way the system selects for capital new nodes is every 2 days it will churn. It will churn the oldest node. This node is most likely to have lost access to its keys. So it's basically, it tries to kick out old nodes regularly. So in a system, you're most likely going to be staying in the system for about 30 days. And then go on. Do we have a question?
You do have a question. What are the technical requirements for a new chain integration? Would a non-Tendermint chain be possible?
Yeah, that's a good question. So like I said, the team have built Bitcoin ETH bridges right now. I'm just going to show you that. And we'll just go through the requirements for such a bridge and what it's actually trying to do. So you can see the actual part of the bridge is outside of consensus. So those who are familiar with Cosmos state machines, all the state machine code, consensus code is in Xdash. Bifrost exists outside of consensus because there's nothing about consensus in the Bifrost because by the time it posts into the chain client, that's when it gets consensus. Now, what to do when you create a new chain client? The team have written an interface that you should basically adhere to. It's been more. It's actually quite simple. All you're trying to do is have a routine that's able to start scanning the chain, and then every time you see a transaction, to basically broadcast that transaction into the state machine. So the start routine will basically start scanning and get these transactions of interest. And we have two routines. One is a signed TX routine, so download from the state machine, and then broadcast. What it looks like for Bitcoin, because Bitcoin is quite complex, Ethereum is actually a little bit more nuanced. But we'll take a quick look at Bitcoin, and we'll just look to the developer branch. Bitcoin, we need to deal with a few more things that we haven't dealt with on, say, Ethereum. So you'll see some routines that deal with things like reorganizations. So I'm just scrolling down here to look at the code. Okay, so things like processing reorgs. So Bitcoin has no concept of finality, and you could call it economic finality once the value of a transaction is less than the value of the economic value of the chain. But Thorchain needs to be able to handle reorgs. So things like scanning the chain, scanning the concept of UTXOs is handled outside consensus, so the Bifrost routine will handle it. But it's able to, basically handle reorgs and stuff like that. The second thing that's important is the concept finality. So Binance Chain has instant finality. So as soon as a node sees a transaction, it can basically fetch it and broadcast it. But for something like Bitcoin, we have what we call confirmation counting. Normally, this is what exchanges call like 6confs. However, 6confs is an arbitrary line in the sand that was in the Mendeley-Rosie paper in 2012, which describes that they don't think will reorg past 6 blocks. But that's actually not true. Bitcoin can be reorged at any depth, and it based purely on the economic value of the transaction. So Thorchain takes us to the next level. So every incoming block, it adds up the value in transactions, and it works out how many confirmations it needs. And basically the rule of thumb is if the incoming transaction is 6.25 Bitcoin, it needs to wait, 6.24 Bitcoin, it only needs to wait 1 confirmation, not 6, just 1. If the incoming value of all the transactions in that block is 12 Bitcoin, then it's going to wait 2 confirmations. So that's how it's able to handle the confirmations required. So the question was, is it easy to connect a chain client to any chain? Yes, we think it is. This is 800 lines of code to deal with Bitcoin, which is not much when you think about it. And this handles all the edge cases with Bitcoin: reorgs, confirmations, UTXOs, mempool, etc. So it's not hard. We don't think it's hard. And there's the team have quite a few different chains on the go at the moment. Polkadot, Cosmos, Zilliqa, Haven, which is a CryptoNote chain, speaking with Avalanche team, and a few others. So we don't think it's hard to build a chain client. You're just basically conforming to a standard and making sure you cover your edge cases inside your own routine. So yeah, that was a good question. The time is now on the 30 minutes, but I think I'll just wrap up. So we discussed how Thorchain, and I use the analogy of a spending script. The state machine is basically an elaborate spending script that only accepts signatures of incoming transactions. We discussed how Thorchain is able to observe and connect to external chains to observe these incoming transactions, and it's able to basically grok user intent. Then we also discussed the notion of vaults is how the system is able to manage all these assets in different vaults and the pooled assets. We also had a quick little demo of how to get this vault through a script or otherwise, and is able to basically use it. And we went through such a script. And lastly, we spoke about the incentive pendulum, which is able to basically direct incentives of the system in order to ensure that all assets in the system are secured by the bond of nodes who are busily trying to enter the system. So these nodes are trying to get into the system, but in order to do that, they need to bring a lot of money. So this is currently about $1 million. So the system will kick out these old nodes and bad nodes, and bring in new nodes with money. And the only way to basically front run is to bond more capital. Cool. Well, hopefully I've answered all your questions about how ThorChain is able to secure assets on external chains using nothing but MPC, multi-party computation, specifically fast multi-party threshold EC2SAY with fast trusted setup, and is able to use incentives to secure those assets. Cool. So if there's any final questions, if not, handing over.
Okay, perfect. I think the last question was just how can we reach you or ThorChain for technical questions?
Sure, you can reach out to the team through Telegram or Twitter, and yeah, the devs are always in Telegram chat to discuss with. But I'm a technical advisor, so you don't necessarily need to reach me. You can just reach the team. Yeah.
Awesome. Well, this was a great talk. We're going to transition to our next session now. Thanks again.
No worries. Thanks all.